The death of the $300 laptop. The bill of materials for a high-end laptop has officially decoupled from consumer purchasing power because 4 companies have pre-purchased the entire global supply of advanced packaging for the next 2 years. In July 2026, a standard memory module costs 400% more than it did in 2024, driven by a $720 billion capital expenditure wave from big tech. Foundries like TSMC have reached a binding constraint where they must choose between printing $500 consumer chips or $80,000 enterprise accelerators. For the first time in computing history, Moore's law is being inverted by sheer infrastructure demand. This displacement is not a temporary supply chain hiccup. It is the structural end of cheap local compute. And the source of this price floor is a technical bottleneck in the way chips are actually put together. The HBM and CoWoS bottleneck. The specific mechanism driving your laptop price to $6,000 is the transition to high-bandwidth memory 4 and CoWoS packaging. These are no longer just server specifications. They are the baseline requirements for running local large language models. However, NVIDIA's new Rubin architecture and the Blackwell Ultra series have consumed 98% of the available capacity for this packaging. When Apple or Dell try to book wafer starts for high-performance consumer machines, they are effectively outbid by hyperscalers who view silicon as a capital asset rather than a retail product. This silicon displacement has forced manufacturers to use legacy packaging for consumer lines, creating a massive performance gap between what you can buy and what the labs are building. But the financial ripples of this build-out are now forcing a reaction from the central bank. The Federal Reserve's new headache. The Federal Reserve is now tracking a specific metric called compute CPI because the massive data center build-out is preventing interest rate cuts. While traditional inflation has cooled, the cost of electricity and high-end hardware is surging at 12% annually. Fed Chairman Kevin Warsh has explicitly cited the $720 billion infrastructure spend as a localized inflationary heat map that threatens to overheat the broader economy. We are seeing a macroeconomic feedback loop where the cost of AI development keeps the cost of capital high for every other sector. This means that even if silicon prices eventually peak, the interest rates on your hardware financing will not. This financial pressure is forcing a fundamental shift in how we actually develop software for the hardware we have left. The signal under the noise. The decoupling of hardware pricing from historical trends signals the end of the commodity PC era for developers and researchers. Because of the silicon displacement in the memory market and the macroeconomic pressure from the data center build-out, local compute is now a high-cost capital asset, rather than a depreciating consumer good. For builders, this means the era of cheap local prototyping on flagship hardware is over, and software optimization for lower-tier NPUs is no longer optional. It is a financial necessity. The gap between those who can afford local silicon and those reliant on metered cloud access will define the next 2 years of software development. As we move toward 2027, watch the quarterly foundry capacity reports for CoWoS allocation. If enterprise pre-orders for the next-gen Rubin chips do not soften, the consumer price floor will stay at these levels indefinitely. Subscribe for more